Well, today we're going to do some hardware hacking Raspberry Pi. So when we say hardware, we want to start with the easiest, with that being flashing an LED. So today we're going to do a switch, which will be the inputs, and we will flash a LED, which will be the outputs. So let me open up my Raspberry Pi manual, and we read a little bit together. So can you guys hear me all right? All right. So this will be chapter 13 and chapter 14. So 2 chapters. Let me start the sharing. So that's what we are talking about. The author covered actually in chapter 14. 13 is some nice background knowledge. I think my mic is over here, so I don't need this. That's my microphone. I guess that's my microphone. Let me check. Yeah, that's my mic. So chapter 13, general backgrounds about the hardware. Well, as a seniors, we probably already know all those information, so we just go through really quickly. It's general knowledge of breadboarding, of soldering, of resistors, the resistor barcodes, of different type of components. Yeah, where to buy those components, breadboarding, soldering techniques. Soldering is a skill everybody should. I'm pretty sure a lot of you are doing very well soldering. I'm pretty good solder when I was a student because I do so much soldering, working on electronics. Yeah, it's a skill. Very easy, but need a little practice. Soldering equipment. Yeah, that's how you solder. So that's chapter 14. Chapter 13. Chapter 14 will talk about number 1, the general purpose inputs and outputs of a Raspberry Pi. So if you look at your Raspberry Pi, that's mine. I have one right here. So if you look at Raspberry Pi from the top, you'll see connectors, 40 connectors. This will be pin number 0. That is the edge. So 2 is on the edge side. So this is the inside of your circuit. So 1, 3, 5, 1, 2, 3, 4, 5, 6. And today, they all have a name. They all have a name. For example, if we zoom in, number 1 will be power. Number 2 will also be power. This can be quite dangerous. That means if you accidentally touch those 2 connectors, pretty much you will say goodbye to your Raspberry Pi because your Raspberry Pi burned. Because 5 goes to 3, it burns those CPUs, which is 3.3. So a good idea, actually, I saw some people sell those plugs which cover those 2 pins. Number 2 and number 4 will be covered. So it prevents you accidentally short 2 to 1 or 4 to 1. That can be dangerous. That's a quick way to, throw away a $50 Raspberry Pi. So today we're going to look at the general purpose IOs. So that will be pin number 17, actually pin number 11, pin number 3, 13, 15, and so on. This can be inputs or outputs. It is programmable. It can be programmed either as inputs or outputs. This create quite a confusion because you see this is pin number 11. It's also called pin number 17. So it's two different ways to name the same pin, which create a huge confusion. So in this class, in this manual, we use this number. We don't use the names. We use the pin numbers, which is how we count it. This is right at 11, 12, 13. So we use this number right here. We don't use the GP. Alternatively, you can use that if you prefer that way. But all the code we are talking about use these numbers right here. So let's look at our circuit first. Different Raspberry Pis have different configurations. Some Raspberry Pi only has 26 connectors. 26. That's the older Raspberry Pi. And this general purpose IOs, some of them have a special purpose. For example, some of them have UART. If you look backwards, there's a UART inside. The UART is a stereo interface. So besides, there are multi-purpose. Because we have limited the number of pins, only 40. You think 40 is a lot of number, is a big number. But for computer connections, it's very small. So a lot of those connectors are multiplexed. They have multiple functions besides as the inputs and outputs. So some of them has UART, can function as UART. Some of them can function as I2C. That's an excellent way to talk to each other. We actually maybe have a lab on that. I2C. I actually have I2C. I did it over the weekend over there, sitting right there, which is a very common serial, another serial. So it's just a different serial. So UART is a serial, I2C is a serial, SPI is a serial, CAN is a serial, USB is a serial, Ethernet is a serial. So look, HDMI is a serial. HDMI, the connector you connect your Raspberry Pi to television, is also serial communication. So everything is just a serial. By serial means they are pushing zeros once, one at a time, out. The only difference is the speed and the format, how they format their data. That's the only difference. Why they created so many serial? Yeah, terrible. Ideally, we just have one serial, universal. So that's actually what we are coming to. We go through this really painful period. So many different types of serial. It's just like before, the power adapters. 20 years ago, every electronics have its unique adapter. It's terrible. Everything you buy, you have to have its own power adapter, a different plug. Same thing for serial. Terrible. Now if you look at for example, Apple, the new Apple MacBook only has one connector. It's a serial. One connector. So that's the ideal world. Get rid of every serial. That's one serial. Unfortunately, that's only Apple. So that's actually create a problem because you have a MacBook, you want to connect to a television, you need to buy an adapter. That's a USB-C to HDMI adapter. So you have buy a bunch of adapters, and Apple charge you $100 for each adapter. So you ended up. So anyway, a lot of serial. So today we start with this guy, flashing LED. So first you need today we do two. Number one is flashing LED. Number two is a push button. So one is the input, one is output. So this will be the circuit for the output. So that's all you need to do. Pin 11, you need a resistor, you need the LED, you need two jumpers. The jumper goes to pin number 6. What is pin number 6? Pin number 6 is the ground. It turned out not only pin number 6 is ground, pin number 9 also is ground. So I will just connect to pin number 9. Why 9 instead of 6? I will explain a little bit, because 9 is easier to access than 6 in my case. In my case, 9 is easier to access. So I plug into 9 instead of 6. So that's the LED. And also, another circuit is the switch. This is the switch. Switch will go to pin number 1, which is power supply. Pin number 12 is the input pin. Pin number 6, I change it to 9. So that's the connection, the hardware connections you need to build. You can use a breadboard or without breadboard. The circuit is so simple, you can do it without breadboard. Last semester, I do not have breadboard. It's no problem. This semester, I have breadboard. But anyway, you can do with or without breadboard. Simple circuit. Once you have the hardware ready, now you need a program. This is the program for flashing LED. So simple. Start to finish. Flashing LED, all you need to do is put those code on Python. So we are coding in Python. So if you look at that code, 11 will be turned on, 11 will be turned off. And then repeat. That's the code, complete code from start to finish, right here. So all you do is cut and paste, and it will loop forever. So that's our first. I will give the demo. So let me start the SSH to my Raspberry Pi. So my Raspberry Pi right here. Raspberry Pi. I will switch cameras, so give you guys a view of a Raspberry Pi. Before I switch cameras, I will share my terminal. Let me share my terminal first. So now you see my terminal. I will plug in Raspberry Pi first. Plug in Raspberry. So once Raspberry Pi is powered up, I can log in to my Raspberry Pi. So I just turn on the Raspberry Pi. It takes maybe 10 seconds. So now I can SSH to my Raspberry Pi. Oh, not ready yet. Oh. Okay, finally. Still not ready. Okay. So I log in to my Raspberry Pi. Now I'm in Raspberry Pi. I will go to my directory. If you look at all the directories I have a directory called Python here. So I will go to that directory. I have a couple examples here. I have 10. Today we'll see the LED, their PY. So this is the exact same code we have on the menu. So all I need is run this code. So how do I run this code? All I need to do is Python LED. So that's how I run my code. So I will run the code, and the LED is flashing now. So you didn't see it because it's over there. So I will switch cameras, and show you guys the flashing LED. Like this. You see that LED flashing? 2 seconds on, 2 seconds off. All right, so that is LED. Very simple, very easy. Let's get closer. It turned off. Why? Because my power connector is not good. I need to switch power connector. This cable is junk. Get a better one. So that's our first demo. The LED is flashing. The second demo will be the switch. So let's go back to the terminal. I lost connections, so I need to reconnect to my Raspberry Pi. I need to go to the Python. So the LED, the next example will be the buttons. So this is the button. So it will basically read from pin number 13. So pin number 13 will be my input. If I push a button, it will print this message. Button is being pressed. So if you look at the camera, I will first demo it, then you may look at the camera. So I run this Python. Before I run this code, pin number 13, okay. All right. So Python, so I run my code, nothing happens until I push my buttons. Oh my, what happened? Anybody explains? Trying to explain what just happened? You see? How many times push button happens? Almost 200 times, maybe more. So that's called the mechanical buttons. Mechanical button, when you push it, it has oscillations, mechanical. So although you only push button once, the computer are so fast. When the mechanical contact contact each other, exactly during that time, there is an unstable state. That unstable will cause the computer to read the button 200 times in maybe a microsecond. So in that very short period of times, that button is pushed 200 times. Obviously, you never want that happen. So that's like your keyboard. You type A, instead of one A, letter A, there's 200 A on your Word document. You lose control. So you have to have something called a debounce. So every button, mechanical, must have a debounce. Right now, this button do not have debounce. Let's look back to the share, the document. This button do not have debounce. So obviously, it's just for demonstration. The not here. Every time you push the button, it created a lot of bounce. And if you just read the pin number 12, in this case 12, but I connected number 13, it doesn't matter which pin you connect to. If without debounce, the computer is so quick, read all the bounces, mechanical bounce. That mechanical bounce is interpreted as multiple times of pushing the same button. In this extreme example I have over there, they have like 200 times. Actually, mine is 200 times because I actually left that button float. When you left that input pin float, it became an antenna. When it became an antenna, it will collect noise, and that noise can create bounce also. So mine is actually a lot of problems. So my button is not no good, but it's just for demonstration purpose. So how do you debounce? You just Google it. You can do a hardware debounce and a software debounce. There are many ways to debounce a button. Let's do a new share of Google. Everybody saw my Google, right? Debounce. So debounce, there's a hardware debounce or software debounce. Which one is better? It doesn't matter. They all works. Debouncing. So every mechanical button you designed must have a debounce, either software or hardware debounce. Let's look at the hardware solution, debounce circuit. So the simplest circuit to debounce is just a capacitor attached to the key, like this one, this guy over here. I don't know why they make it so complicated. Anyway, this way debounce right here. So this capacitor here will smooth out all those bounces. This capacitor right here. So that's the simplest one. Of course, there's more fancier ones. There's another one, debounce. That's another debounce circuit through a amplifier. That's the ultimate debounce. Yeah, this is excellent debounce circuit right here. Through a latch, through a RS latch, debounce. That works beautifully. That will get rid of all the bounces. Of course, you can write a piece of software to debounce. Let's do the debounce code, right? So you can have software debounce, whatever C code or Python or whatever code you want debounce. That's debounce code. So it's a problem. It's a simple problem, not complicated problem. All right, any questions so far with our subject? I got a couple of emails. Somebody says they were on vacation, so for a week or something. So this week, we might have now we have two. So let's go back to our Raspberry Pi. So that is pretty much all the materials of chapter 14. So this is author's demo. So every time you push a button, the terminal will have a display. We'll put something here. All right. What we are here, so we are going pretty quickly through the other chapters. Chapter 15 will be attach a camera module. So if you look at Raspberry Pi, there's a special connector. That connector is just for cameras. It's called the Raspberry Pi camera module. So it's a camera module, look like this, with a cable which plugged in directly to Raspberry Pi. Right here. So you plug your camera right here. Do you have to buy one of those camera modules? No. Previous years, some students do buy the camera modules because it's small and tiny, looks very nice, but you don't have to. If you want the camera functions, 100% function can be, the same function can be done with a USB camera. So that's what I do. I have a couple of USB cameras. So I can't find one of those right now, but I needed to plug in a USB camera. So it has the same function. The only difference is initial setup. Actually, it's automatic. The USB camera works automatically. So as long as you plug in, it will work. So that is a topic. So that's the camera module plug-in. Enable the camera. The USB camera and the Raspberry camera module, the enable procedure is different. I think the USB is easier. So that's a camera module. Take a picture, take a video. Ultimately, we will build a security system. The security system is based on a software package called Motion. Motion is a very complicated software package. We can use Motion. We can use Motion to build a security system. Motion is not very friendly, but it's not too bad. So you can use Motion directly. In order to make it more friendlier, there is a Motion OS. I forgot the name. Make the Motion more user-friendly, like a Windows interface for Motion, a graphic interface for Motion. Well, you can choose either the graphic interface for Motion, or you can just control Motion directly without that graphic user interface. That's what I did. I do not use the graphic user interface. I have Motion running right now, facing my front yard. I can demo my Motion camera. We are here. Let me see a demo of Motion. So in order to see the motion camera. You see my web browser, right?
Yeah.
This may be my backyard. Let's see. This is my ad blocker. That's another project you can do called a pie hole. If you want to do a pie hole, that's an ad blocker. I put this ad blocker. So if I do not want ad, I can use pie hole. It's a screen. Let me demo a pie hole once we are there. So this is the pie hole. You can do this project. It's a nice project to have. Right now I have 235,000 on block list. You see here? Jimmy, you saw that?
Yeah.
Yeah, on block list, that's the website I do not want to go to. 235. I remember I have 2 million before, but maybe I changed it somewhere. I forgot. So this block list. So if you click on some web page, it will try to get to those block lists. It will stop it. So that's the pie hole. Pie hole is a good project. I put a pie hole around my house for almost a year. I even forgot about it. So I was surprised when I go there. I see the pie hole because actually I forgot about that pie hole.
Dr. Zhang?
I forgot my camera. Maybe.
Hello?
No.
Can you hear me?
Okay. No cameras.
Dr. Zhang?
So I forgot the location of my camera, but anyway, that's
Hello.
that's motion.
Hello? Hello?
So this is a chapter 15. Talk about the cameras, recording videos. Motion will automatically capture video if it detects motion. If some intruder, if some people is moving in front of the camera, it will automatically record videos and take pictures. So that's the camera. The last chapter. So today we pretty much finished our first document, which is the user guide for Raspberry Pi. The last chapter talk about add-on hardwares. There are many add-on hardwares. If you look at if you Google it, you will find a lot. I actually was thinking about buy a TV add-on module, which will watch TV on my Raspberry Pi. But I didn't. I ended up buying another module right it's sitting in front of me. It's actually much better than the Raspberry Pi TV module. So I'm using that one right now. It's but anyway, there are many different types. The one I want to do a little talk a little bit about is there's a touch screen module. Previous years, some students did a touch screen. Excellent way to use Raspberry Pi. Now you have Raspberry Pi operating system running a touch screen. It's much more user friendly. You have you don't need a mouse. You don't need a keyboard. All you need is your finger, right? Your finger control the. So that's that part. Power supplies. Oh, touch screens. That's how to connect them. The one module I want to talk about is called the HAT module. Hat is a standard format. This is a Sense hat. So there are different hats. You can buy a TV hat. You can buy a Sense hat. You can buy a lot of different type of hat. The hat will plug directly to Raspberry Pi. So those 14 pins will plug directly on top of Raspberry Pi. This hat module is very nice. It has LED matrix. It's by 8 by 8, you see, or 7 by 7. So you have 49 LED, and then you have various sensors like temperatures, directions, motion. You have various sensors on the hat. Installation is very easy. All you need is a plug-in. So that's a plug-in, the hat plug-in to the Raspberry Pi. And you can display text messages on your LED. So right now you have, looks to me like a hello. The text message can roll forward. So you can see the complete message. And then you can experiment with different code, different type of code. So that's the end of all the document. So that's what happens if you do not have a Sense hat. If this hardware costs $30. So what if I do not want to spend $30? Still, I want to experiment. Nice thing about that is Raspberry Pi come with a simulator. So it simulates what happens if you have a hat module. So that's the last part I'm going to do here is a demo this simulator. In order to demo the simulator, first you need a VNC. So you need a VNC to your Raspberry Pi. So let's do that. I will connect my Raspberry Pi through VNC, and then I will share that VNC screen. So now I'm connected. So let's start sharing. So now it's VNC to my Raspberry Pi. If you notice, my Raspberry Pi is only plugged into power. There's nothing else plugged into my Raspberry Pi, only power. So everything I want to do on my Raspberry Pi, I have right now 5 Raspberry Pi around my house. Every 5 of those attach only to power. Some attach to USB camera, so that's only connection. USB camera and a power. I can put it around different location of my house as a security camera. So wherever it has power, I can just put Raspberry Pi over there. The only thing is that it's indoor. So if you want to put it outdoor, you need something protection for outdoor. I actually put a couple outdoor, but I decided not to do it. I found out not very good because the rain, the water, the moisture can get into it, even though. So you need pretty good protection. Otherwise, it doesn't last very long. So let's look at the where is that Raspberry Pi hat simulator? Okay, right here. This simulator, you can play with the simulator. So it's just as if you got the simulator right here. As if you have the hat plugged in. So you can play the different sensors, temperature sensors. You can measure temperatures, not real temperatures. You can measure pressure. It's not real actually. If you have that, you can measure the real pressure around your house, the humidity, the directions of your hat. Also, you can put different letters on the display. So it's a nice simulator. Open examples. Bar graph. Let's do that example. How do we run this code? Okay, run. Okay, I started run my code. You see the barcode is there. So this is one demo. So all the demos is Python. So that's barcode demo. Can run another demo. Try line graph rainbow. Let's play that. Run modules. And we got rainbow displayed on my Raspberry Pi hat, Sense hat module. So those LEDs are actually color LEDs. Potentially, you can do a lot of different graphs over there. I see one of our website show off a project the student did many years ago, 2 or 3 years ago. They did a 10 by 10, if I remember correctly. Maybe not 10 by 10, 8 by 8 maybe. LED matrix, just like that. And they can put some different colors, different patterns, flashing different images. And that was their project. And we can do it here with Raspberry Pi. So very easy. You just buy one of those modules, plug in, and run that Python code. It will put that color. Of course, you can always modify it to make it your own pattern. So that will end today's instruction. So we did on Thursday when we coming back, the lab session. Hopefully you guys will have a couple of jumpers like I have over here. Let me show what I have. Let me show my setup. So hopefully you have something like this over there. That's all you need. That's all you need. All right. You need one resistor. You need one resistor right here. One LED, a jumper. You need to open up your Raspberry Pi case. And you need to plug in. Why I do not plug into pin number 6? Because pin number 6 is almost impossible in my case to plug into. Pin number 6 is hidden on that corner. So instead of pin number 6, I use pin number odd numbers. I use odd numbers, not even number pins. Even number pins is kind of difficult for me to plug into. And that's pin number 1. That's power. I use red color. And this will be the jumper I simulate as a switch. So I will go from here to black. The black is ground. The red is power. So when I'm pushing a switch, I will just unplug it and plug it right here. That be my simulation of push buttons. So I do not have a push button. So I would basically use a jumper, alternatively go between power and ground. When I go alternatively between power and ground, it simulates a button is being pushed because that's exactly what happens when you push a button. You change this input. Right now it's pin number 13, pin number 13 right here. I didn't use pin number 12. Again, same reason. Pin number 12 is hidden inside, unable to attach to it. Very difficult for me to plug into, so I use pin 13. And I plug into Okay, we only have one left. Jimmy, you have any questions before
Wait, can you hear me?
we
Hello?
finish?
Hello?
Oh, I need to, where am I? I can hear you without this. Yeah.
Oh. Wait, what'd you ask?
Do you have any questions before we?
I don't think so.
Okay.
Wait, jumpers? You said we need jumpers?
No, yeah, you need jumpers like this type of jumpers. You need jumpers look like this.
Okay.
One side plug into the Raspberry Pi. One side is like a needle.
Right. Because see, we got a lab kit from eet402, but I don't think they come with jumpers, so I might have to get some jumpers then.
Yeah. Looks like you need four of those.
Four of them? Okay.
Yeah. So one side can plug into Raspberry Pi. The other side can plug to the.
Could I borrow some from the lab?
Yeah, that's what I think should because you only need probably 4 or 5 from the lab. Yeah.
Okay. Well, actually, I'll be at the campus on Wednesday, and then I'll.
Yeah. I think everybody just borrow 4 or 5 because we have limited supply in the lab.
Yeah.
So yeah, you need a jumper like this.
Okay. And then for the you said for the USB camera, so like.
Just plug in.
Like a USB webcam too, because that's what I'm using.
Yeah, webcam. USB webcam. Yes.
Okay.
I think everybody have a couple, around. Yeah.
Right.
Any
what if you
old
use
one?
a GoPro?
Yeah.
You can use a GoPro too?
I have a Go. Oh, yeah, that's a good idea. I have one, but I have to find that out. Yeah. That can be used as a USB camera, the Go?
Yeah, because it has a USB-C and then a USB, so you can plug it into your computer. But
okay. Good suggestion. I will dig out my Go camera, GoPro. I have an old one, GoPro 3 or 4. I forgot.
Okay.
I haven't used quite a while, but that's a good idea because it has a high quality camera.
Yeah.
Yeah. That's all you need is a camera. Any web camera will work. Yeah.
Okay. All right. That should be it for me then.
Well, we will talk about the motion later. Later, how to set up the motion so you can have a security system.
Yeah. Well, like my garden needs a motion detection because, like, deers try to eat my garden.
That's a good way. Yeah.
Yeah.
Catch those deer. Yeah.
Yeah.
Instead of buy those from Walmart, like $50 each, that's cameras.
Yeah.
Those are actually better because those are designed for outdoor. They are tough.
That's true.
Yeah. But you can also use your Raspberry Pi. Make sure you build a good case for it.
I know. Yeah.
Like go to your kitchen, find one of those plastic case for leftover food. Some of them are very well built. Yeah.
Get some solar panels and just have it self-powered.
That's right. Solar powered is a great idea. That would be a good product. We actually have a semester project. That would be a good semester project. You put a solar panel, put a charger, little charger.
Yeah.
I actually have a couple of those. I buy those at Walmart, Menard, for $1 a piece. Those are solar powered LED lights.
Oh wow.
$1 solar. It's outdoor solar powered LED lights. all I did, they have LED solar panel and a charger and a battery already inside. Everything is there.
Wow.
So all you need is take out the LED and plug in your Raspberry Pi.
That's cool.
Yeah, that will be the simplest way. Otherwise, if you buy separately, you need a solar panel, you need a charger, you need a battery, chargeable battery. Yeah, it's a lot of work.
You bought it at Walmart?
I bought it at Menard.
Menards, okay.
Yeah, on sale. Once they have this like $1. Very well built. They have a stainless steel case, very tough case. Protect everything is well protected.
Okay.
Yeah. You might buy one of those solar lights, like garden lights, and you attach your Raspberry Pi to the garden lights. They have solar-powered garden lights. They have like 12 of those garden lights. Yeah.
Right.
And they have a solar panel, charger, everything ready. Yeah.
Well, there you go.
Yeah. So you have now you have a garden lights, and also another thing about camera is the web camera. High quality is good because you want to catch deer. It's low light at night. If you use some of the camera is terrible at like low light condition. Yeah.
Yeah, you don't want cheap cameras.
Yeah. Also infrared. So if you want the infrared, there's the infrared Raspberry camera.
Oh, that's cool.
Just Google it. Infrared Raspberry Pi camera. One of our students did the infrared. It's light up. Complete darkness, you can see it. It's infrared because they have built-in infrared lights around the camera. So at night, you turn on the lights. It's invisible to human, but that light is infrared, and you can see complete darkness.
Oh, that's cool.
Yeah, it's night vision.
Yeah, I think that's what I have. I have like a motion. Okay, never mind. It's motion detection, motion sensing. It's not infrared. Never mind. But it's for deer still. Like if it senses like something moving, it will flash the lights and make a high pitched sound to scare the deer away.
Oh, does it work?
I think so.
Okay.
We haven't seen them eating the green beans.
Yeah, let me Google infrared. Yeah, you can buy one of those. Yeah, those are infrared. Night vision.
Wow.
$13, yeah.
It's not bad.
These are the infrared lights. These are the cameras.
What is the right there? A Raspberry by Raspberry, and it's a camera version 2. It's your left.
Yeah, that's a high definition. That's a camera 2 module. Yeah.
Oh wow, it's $30.
Yeah, this is $30, but it's 8 megapixel. This is very high quality. This is 8 megapixel.
Yeah.
But this is not infrared.
No.
This is not infrared.
Yes, lights?
No, it's just a camera. There's no lights. But this works very well with the Zero. You see the Zero?
Yeah.
Zero is a tiny Raspberry Pi. And with a tiny case and tiny camera, you build a tiny security package, very tiny, like a pack of gum. Yeah. Yeah, this tiny little bit.
Wow.
That's a Zero. Zero has a Wi-Fi, so you can put it anywhere.
That's cool.
Yeah. Yeah, that's good project. That's why people like a Raspberry Pi camera, because it's tiny, small.
Yeah.
And it's attached to the Zero very nicely.
Can you like attach a camera to like a remote control car and then have goggles and then
Yeah, that's actually one project I did with my son. We have a wireless webcam on a vehicle, which can be remote controlled by a cell phone.
Oh, okay.
Even if I'm not home, I can VNC to our home and then control the vehicle, which has a camera on top of it. So I can see around my house, driving the vehicle around my house and see. So that webcam, security camera, you can put this security camera in a fixed location. Now I have a vehicle to carry my security camera around my house.
Yeah.
Yeah.
That's funny.
That is I did with my son. I use Lego Lego robot.
Oh, okay.
Have you ever used those Lego?
No, not really. I mean, I built Legos, but not the robotic kinds.
Yeah, Lego Brainstorm. Those are the Lego robots. We have a controller, and which is a computer. Yeah, these are the controller. You have.
Right.
This is the Lego robot. We actually bought the whole package, education package. So this Lego, that's the controller, and you can build whatever you want to build, and then you program it, and it will be a robot. All kinds of robots, hundreds different types.
For $350.
Yeah, that's only one robot. I buy the complete package. That's $1,000.
Wow.
And then there is another box of Legos. So if you want to build more different types, I actually bought another one. I forgot how much the other one cost. So yeah, they call the Lego Mindstorm.
Okay.
Actually, I don't like that platform because the most time you spend is building the Lego pieces.
Right.
You spend hours building these little pieces. And this part only takes you like 2-3 minutes. If you have the code, all you need to download the code.
Right. But that's like 500 pieces.
Yeah, a lot of those are very complicated. This is I have a couple projects. Lego. It's sitting over there. I have it over the corner. Let me show you. This is actually a nice one. It actually have 2 views, and you program this Lego, it will stand on 2 views, not falling.
Must be a volley.
Yeah, it can walk. It can walk on 2 wheels.
Huh.
It's not a 4-wheel vehicle, 3-wheel. It's very top heavy. It has a sensor to keep it upright, not falling. And then you can tell it to go forward or backward and turn with 2 wheels.
Wow.
Yeah, that's one of the projects. I did a couple. I was hoping to get my kids get started with engineering, electronics, but both of them are not interested in electronics engineering.
Oh.
So, yeah. Yeah, I tried.
What are they into then?
One is I think my daughter, she decided to do computer science, software. Yeah, the math part.
Yeah.
She is a interested in mathematics. So my son, I don't know. He probably, I don't know. He hasn't decided yet. Probably go to medical. I don't know.
Yeah. Well,
I'll stop recording and